And then just a probability a glance that hard questions I am going to discuss here. And then now problem is many of the portions are deleted now. And then mainly the Bayes theorem and that total probability theorem, mainly that concept we are going to test, we are going to discuss here. Even though you know very well all the concepts, and then just I will share my experience, and then some hard questions I come across during the board examinations in this topic. I'm going to share it here. We'll discuss, and then feel free to ask questions, and then feel free to discuss anytime. You can stop me, and then you can suppose if you have a better method of doing the same problem, you can tell us here so that I can follow it up in the next class. But I'm going to face a student. When I go to face the students, I'll go with the new method if it is easier than this one. Please feel free, teachers. Please come and give your suggestions, give your comments then and there. That is most welcome. So we are going to. I'm going to see that it is. Yeah, first of all, before going to the Bayes theorem, what is called the partition of a sample space. Partition of a sample space. This concept, I think we ought to explain to the children. First of all, what is a? Then only they can understand where to apply the Bayes theorem and how to apply the Bayes theorem and all. They can understand very well. So the partition of a sample space concept is very important. And then the law of total probability, a rule of total probability theorem, then comes under the Bayes theorem. So a set of events, E1, E2, E3, etc., En, is said to represent a partition of a sample space. Partition means separate the events, separate sets. Okay, there is no, that's called disjoint, pairwise disjoint. Otherwise, we can say mutually exclusive events. Means if we take any two events, their intersection is empty set. That's what. Okay. If there are three conditions, one is pairwise disjoint. Pairwise disjoint. So if we take any two events, their intersection is empty set. Therefore, they are disjoint events. The intersection is empty set. Or we can say that the mutually exclusive events. And the E1, E2, E3, etc., En are exhaustive events. Exhaustive event means that the union of all the events is equal to the sample space. Yes. The union of all the events is equal to sample space. Therefore, the set of events are exhaustive events. And with the non-zero probability of occurrence, each event with a non-zero probability of occurrence means that the probability is not equal to 0. There is a greater than 0. It must be greater than 0. Of course, we know that the probability of any event lies between 0 and 1. So it must be greater than 0, not equal to 0. So it non-zero probability. These are the three conditions. If it satisfies any set of events, satisfy these three conditions, we can call them as a partition of a sample space. The set of events is said to represent a partition of a sample space. Okay, we have to check the set of events that partition of a sample space or not. So pairwise disjoint, exhaustive with a non-zero probability of occurrence. So these are the three conditions should satisfy the set of events in a sample space. Then it is called a partition of the sample space. And here the letter A is any event associated with the sample space. A is any event associated with the sample space. Yes. Then the total probability theorem comes here. The theorem of total probability. That is, I think that the partition of sample space is clear. Now, let E1, E2, etc., En be a partition of the sample space, yes. And let A be any event associated with the sample space, yes. Partition of the sample space means it is understood that they are pairwise disjoint, exhaustive with a non-zero probability. And A be the any event associated with the sample space, yes. Then probability of A is equal to is equal to probability of E1 into probability of A given E1. Probability of A given E1 is a conditional probability. You know that the conditional probability of probability of any event E, given that the probability of the F has occurred. Probability of E given F is called conditional probability. That is probability of the event E, given that F has already occurred, is called the conditional probability. So probability of A given E1 is a conditional probability. So probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2 and so on, plus probability of En into probability of A given En. So this is called the total probability theorem. Total probability theorem, because the A is an event associated with the sample spaces. So the probability of A intersection E1 is a part, is it? If you add this, you will get the total probability theorem. Or otherwise, the summation notation, sigma I is equal to 1 to n, probability of EI into probability of A given EI. That means the sum of all is representing using the summation notation. So the total probability theorem. So how this theorem is derived, even though the proof is not required, but it is a simple concept only, the proof of this theorem. For any event A, that A is equal to A intersection S, where S is a sample space. A intersection S is equal to A, that we know that already very well. So here S is the union of all the events E1, E2, E3, etc. En is a partition of the sample space. And they are exhaustive events, already you know that. So A intersection of E1, union E2, union, etc. En. So by using the distributive property, A intersection E1, union A intersection E2, etc. union A intersection En. So the probability of A is equal to addition theorem. Probability of A is equal to probability of A intersection E1 plus probability of A intersection E2, etc. Probability of A intersection En. Now, by using the conditional probability, probability of A intersection E1, by using the conditional probability. So probability of A intersection E1 is probability of A given E1 is equal to conditional probability. Probability of A intersection E1 over probability of E1. This is a conditional probability, you know that, because this is a basic definition. I did not comment that I'm not going to explain this. Already we know that conditional probability. So from this probability of A intersection A1, it is derived, is equal to probability of E1 into probability of A given E1. Okay. So like that, all the terms are expressed here. The sum of all the terms is equal to the total probability theorem. The probability of A is equal to sigma I is equal to 1 to n, probability of EI into probability of A given EI. Okay. So this is called the total probability theorem. By using this theorem, just we'll see one simple example. Then 2-3 examples we'll see, and then we'll go for some hard questions and Bayes theorem questions. So here a bag contains 4 red balls and 3 black balls. So here bag 1 contains 3 red and 4 black balls. And bag 2 contains 2 red and 4 black balls. 2 red and 4 black balls here. So one of the bag is selected. So let E1 be the event that selecting the bag 1. Selecting bag 1. Random selection only. So E2 be the event that selecting bag 2. Selecting bag 2. One of the bag is selected at random. So choosing the bag 1 and bag 2 is the probability is 1 by 2. So probability of E1 is equal to probability of E2 is equal to 1 by 2. let A be the event that from the selected bag, one ball is drawn and find the probability that the ball drawn is red color. So the one ball drawn from the selected bag, one ball drawn from the selected bag is red color. This is the probability, that is the A, event A. So now we are going to find out probability of A given E1, the conditional probability. So probability of the one ball drawn from the selected bag is red color, given that it is taken from bag 1. So bag 1 red color ball is a 3 red color out of 7. So 3 over 7 is the probability. And the probability of A given E2 is equal to the selected ball is red color. One ball drawn is red color, given that is taken from bag 2. So back to 2 red ball and the 2 red ball, 4 black, 46. So 2 out of 6 is a 1 by 3 is the probability of A given E2. So by using the total probability, this is a simple example only. So probability of A. So the question is, find the probability that the ball drawn is red color. So that is the total probability theorem. So probability of A is equal to probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. That is equal to 1 by 2 into 3 by 7 plus 1 by 2 times 1 by 3. That is 3 by 14, right? Or 1 by 2 can be taken out. 3 by 14 plus 1 by 6. Am I right? 3 by 7, 1 by 2 into 3 by 6. Yes. The total is by 14 and 6, 42. 42 is LCM. So 9, 3, 14 is 42, 7 plus 7. So 16 by 42. Am I right? Am I wrong? Something else. Probability of A given E1 is 3 out of 7. This is 2 out of 6 balls. One ball is red color. Correct only. So 1 by 2 into 3 by 7, 3 by 14, plus 1 by 2 into 1 by 3, that is 1 by 6. So 42 is LCM. 3 14s are 42. So 3 3s are 9. And 7 6 are 42, 7. 16 by 42 is answer. Yeah. So like that you can do, but anyway, I will go to the next question. Yeah. This may be a little complicated. This is also a board exam question. A speaks the truth in 60% of the cases. A speaks the truth in 60% of the, sorry, before that one more question is after this will come back. Yeah, cards are numbered from 1 to 25. Cards are numbered from 1 to 25. 2 cards are drawn one after the other. 2 cards are drawn one after the other. Find the probability that the number on one card is multiple of 7 and on the other is a multiple of 11. What is the probability that the number on the first one card is multiple of 7 and the number on the second card, another card, is a multiple of 11. So how to find the probability? So cards are numbered from 1 to 25. So if you see that it is 1, 2, 3, etc. It is up to 25. And then multiple of 7. What is multiple of 7? So multiple of 7, it is 7, 14, and 21. And the multiple of 11 is 11 and 20. This is less than 25. These two numbers, these two sets are only possible. So the question is, find the probability that the number on one card is multiple of 7 and the other is a multiple of 11. So how to do that? So let us have let E1 be, let E1 sorry, let E1 be the first card drawn is a multiple of 7. First card drawn is a multiple of 7. M7 is a multiple of 7. Let E2 be there, even that. The second card drawn is a multiple of 7. Okay. And the F1B, first card drawn is a multiple of 11. And the F2B, the second card drawn is a multiple of 11. Multiple of 11, like that. So the required probability is, what is the required probability? The required probability is that, so probability of E1, the first card drawn is multiple of 7. Probability of E1 into the second card drawn is multiple of 11. Second card drawn is multiple of 11 means second card, there is F2. So probability of F2 given the first card drawn is this one, E1. The first card drawn is here, multiple of 7. Or the first card drawn is a multiple of 11. So probability of F1 into probability of E2 given F1. Am I right? F2 given E1 and the E2 given F1. Yeah. So now we can answer the question. What is the probability of E1? The first card drawn is a multiple of 7. That is 3 by 25. 3 out of multiple of 7 means 3 possibilities are there. 3 out of 25. And what is the probability that F2 given E1? So what is the probability that the second card drawn is multiple of 11? Given that the first card drawn is already one card is drawn, therefore it is 2 by it is 24, right? So 2 cards are multiple of 11. So given that already one card is taken, yeah, or probability of F1. So probability of F1 is 2 by 25 multiple of 11. Given that, so and then the second card drawn is a multiple of 7. So 3 divided by, given that already one card is taken, that is 3 out of 24. Am I right? So the product will give the correct answer. So 3 by 24. So maybe we can take that 25 into 24 is LCM. 6 plus 6, 12. So 12 by 24 is 1 by 2. So 1 by 50 is the required probability. The required probability is 1 over 50. So this is by using the total probability theorem only. But you can do directly also. If it is a multiple choice question or something like that, you can do directly. If it is show the steps means, you can go like that. A speaks the truth in 60% of the cases. A speaks the truth in 60% of the cases, and B in 90% of the cases. In what percentage of the cases are they likely to contradict each other in stating the same fact? So, Uma ma'am, hello.
Yes, sir.
I think.
Yes, sir. Sorry, mic is on.
Okay, that's fine. No problem. A speaks the truth 60% of the cases, and B in 90% of the cases speaks the truth. In what percentage of cases are they likely to contradict each other in stating the same fact? Contradict each other in stating the same fact, or they agree in the stating the same fact? In what percentage of the cases are they agree in stating the same fact, or what percentage of cases they contradict each other in stating the same fact? This was somewhat, they find it difficult, the students, that's why I'm sharing with you. That time it was, they find it, many of the middle mediocres, they find it difficult. And some top students they have done, and the low achievers and the average students, they find it difficult to do this problem. So how to handle this problem? Let E and F be the events that let E be, A speaks the truth. Let E be the event that A speaks the truth. Well, A be the event that A speaks the truth. And let F be the event that B speaks the truth. Okay. So the probability of E is equal to 60%. That is 3 by 5. And probability of F is equal to 90%, 90 by 100, which is equal to 9 by 10. Okay. We have 9 by 10. And therefore, here E and F are independent events. E and F are independent events. So E and F are independent events. We know that. And then A and B, what is the question is, A and B contradict each other in stating the same fact. Contradict each other means, suppose if A speaks the truth, then B tells lie. Or if A speaks lie, then B speaks the truth. That's called contradiction. Okay. So the probability of A and B contradict each other in stating the same fact. So we are going to find out the probability of.
Sir.
Yes, sir.
Sorry for disturbance, sir. Ishwar.
Welcome, sir. Welcome, sir.
Sir, to get easy calculation, can you keep 100 as it is, sir?
Pardon, sir? Pardon? I'm not able to get
denominator place.
100 you can keep, sir. Oh, yes, yes.
If
fine.
we keep 100 as it is, the students will do easy, sir.
That is also fine. Yeah.
My view, sir. Just my view.
Yeah, sure. Yes, sir. It is correct.
Because 5 and 10 means again they want to do LCM.
Yeah, sure. You can keep it.
You.
Yeah, welcome, sir.
Sorry for disturbance.
Yes, it is possible, sir. You can keep it 100. So probability of A and B contradict each other. In stating the same fact, that is equal to probability of E intersection F dash, means probability E speaks the truth. Sorry, that means A speaks the truth and B tells lie. Or A speaks the lie, tells lie, E dash, and B speaks the truth. If you can keep it, or A itself, we can keep it also. A intersection B dash also you can keep. Anything we can name it also. That is also easier only. So by using the independent events, so if E and F are independent, E and F dash also independent. So probability of E into probability of F dash plus probability of E dash into probability of F. So probability of E is already, we know that 60 by 100. You can easy calculation, we can keep also. Into probability of F dash is 1 minus
10 by 100, sir. 10 by 100.
10 by 100. Okay. 10 by 100. Plus this E complement is
40 by 100.
40 by 100 into
90 by 100.
90 by 100. Okay. So we can have the calculation easier. Okay.
600 by
600.
10,000, sir.
Yes, sir.
Plus 3,600 by 10,000, sir.
Yeah. 600 plus 3,600
by 10,000.
By 10,000.
So 4,200 by 10,000.
Yeah. So 4,200 by 10,000. Okay.
42%.
42%. Yeah. They contradict each other. Okay. A and B contradict each other in the 42%. Yeah. 42% of the cases, A and B contradict each other. And then the second question is agree. Agree means agree in stating the same fact. Means I think without calculation also the remaining, the 42% means remaining 58% they agree the same fact. Also you can do that. Agree means both of them agree. Either a probability of E intersection F means both of them speak the truth, or both of them speaks the lie or tells a lie. So probability of E intersection F plus probability of E dash intersection F dash. Both of them speaks a lie. So they are agreeing each other. Both of them speaks lie or both of them speaks the truth. So that means they agree each other. So that in that, if you calculate the same like that, you will get maybe the remaining 58% of the cases, they agree each other. And the 42% of the cases, they contradict each other in stating the same fact. That's what. So this question was also discussed by many children, but some of the children could not able to do the problem during that time. That's what I wanted to share this question. And then we'll go to Bayes' theorem. I think Bayes' theorem, we know that already, no need to explain. If E1, E2, E3, etc., En are n events with the which constitute a partition of a sample space. Partition means it is pairwise disjoint, exhaustive, and with a non-zero probability of occurrence. And A, B, any event associated with the sample space, yes. Then probability of AI given A is equal to probability of EI into probability of A given AI divided by the total probability. The total probability, that is P of A. This is called a Bayes theorem. So by using the Bayes theorem, there are a lot of hard questions asked at the board examination, and we'll share as much as come across. A bag contains 4 balls. A bag contains 4 balls. 2 balls are drawn at random. It's a 6-mark question. It was asked in the year 2010, I think so. 2010 board paper. It was a tough question, 6-mark question. Many of them lost the center because of this question. That year was one 6-mark question was very tough. That this is the question probability. A bag contains 4 balls. 2 balls are drawn at random and are found to be white. 2 balls are drawn at random and are found to be white. What is the probability that all the balls are white? What is the probability that all the balls are white? This is the question asked in the board exam. 2010 board exam, I think. It is already paper. And then the time, I find it's very tough. This question is very tough. Many children, they were spending a lot of time fun, but some of the children did that question. You know, maybe steps somewhat they got confused, and then some of the children did. Many of them did not do this question because they didn't understand which method has to be approached. We have to approach which method or which comes under which topic. They are unable to find out. A bag contains 4 balls. 2 balls are drawn at random and are found to be white. What is the probability that all the balls are white? So 4 balls in the bag. So what are the 4 balls? We don't know. What are the 4 balls we don't know. The question is, all the balls are white. What is the probability that all the balls are white? That's the question. But we don't know what are the balls in the bag. So we may guess that minimum 2 balls must be white. Yeah. Minimum 2 balls are, because it is given that 2 balls are drawn from the bag are found to be red. Sorry, found to be white color. So minimum 2 balls will be white, and the other balls we don't know. So that let us see that. Let E1 be even that the bag contains 2 balls in a bag contains and 2 white balls and 2 non-white balls. NW means non-white. It's not white. Okay, 2 balls are white and 2 balls are not white. This may be a bag. So that may be another assumption is a bag contains 3 white balls and 1 non-white ball, not white ball. Or E3 is another assumption. Bag contains 4 of them white balls and 0 non-white. Nothing is there. That is 4 of them are white balls. These are the 3 cases possible. 3 possibilities are there. E1, E2, E3. 2 white balls are 2 of them not white, other colors, and 3 white ball and 1 not white, and all the 4 may be white balls. These are the 3 possibilities are there. And therefore, choosing a bag is a random experiment only. Therefore, so probability of E1 is equal to probability of E2 is equal to probability of E3 is equal to 1 by 3. Because choosing any bag, any one of the bag is 1 by 3. Now, let A be the event that the 2 balls drawn are found to be white. The 2 balls drawn are the 2 balls drawn are white. This is a associated event, the event associated with the sample space. So probability of A given E1. What is the probability of A given E1? The 2 balls drawn are both white color. Okay. Given that it is taken from the first bag. Sorry, the first E1 bag contains the 2 white balls and the 2 non-white balls. What is the probability? So 2 white balls are drawn. So that means 2 white balls are there, 2 are selected, 2C2 divided by, and then 4 balls are there, out of that 2 balls selected, that is 4C. So 2C2 is 1 divided by 4C2 is 4 into 3 by 1 into 2, which is 6. So 1 by 6 is the probability. So probability of A given E2. That is the 3 balls are white. Among the 3 balls, 2 balls are taken. So 3C2 ways we can select divided by 4C2. How much? 3C1 is 3 by 6. 4C2 is 4 into 3 by 1 into 2. It is 3 by 6 is equal to 1 by 2. We can keep otherwise. So probability of A given E3. All the 4 balls are white. So 4C2 by 4C2 is 1 is the probability. So this is 1 by 2 is the probability. So the question is, by using the Bayes theorem, probability of E3 given A. Because all the balls are white. What is the probability that all the balls are white, given that the 2 balls drawn are both white balls? Okay. So E3 given A. That is equal to probability of E3 into probability of A given E3. That is 1 by 3 into 1 divided by 1 by 3 into 1 by 6 plus 1 by 3 into by is the total probability. 1 by 2 plus 1 by 3 into 1. So 1 by 3 can be taken out common and cancel. The remaining is 1 divided by 1 by 6 plus 1 by 2 plus 1. If we take LCM as 6, 1 plus 3 plus 6 divided by 1. Am I right? So it is 6 by 10 which is equal to 3 over 5. Yeah, is it 3 over 5? So a lot of discussion was going on during that time. So we have to, what about 0 white ball, 1 white ball? In that case is what shall we do? So many discussions went on during that time, 2010, I remember. And then even we teachers found after the, actually 10:30, the board exams started. 11 o'clock, we were able to see the paper in the, just to go in to see the paper with team of teachers. And then after finding that question, no, we found very difficult and then embarrassing. So this question was, then after 1 hour discussion only, we came to know that this question can be solved by using the Bayes theorem by that. After all that, we teachers find it this much difficult, and then students, what they will do. And then even though some students, they did well, they did the question. But that time, that year, the centum was very less. Many students lost the centum. And also this marks also lost. Because they are not able to proceed with that question. Only very short. A bag contains 4 balls. 2 balls are drawn at random and are found to be white. What is the probability that all the balls are white? So that time in the tension and the pressure, a lot of pressure, they were not able to think about this question. That's what. After that, they came out of the exam. Many of them, they understood very well. Any of this question was that year 2010, we cannot forget that board exam. Okay. That was my experience during the board exam. Okay. Is there any question here? Any doubt or anything you wanted to give comment on this? Please, teachers. Otherwise, I'll go to the next question. So Bhavani is going to play a game. This is somewhat recently I found that question in some of the paper, sample paper. I don't think it is. I don't know. It's some of the question paper, some other school's paper I have found. Bhavani is going to play a game of chess against one of 4 opponents in an inter-college sports competition. Each opponent is equally likely to be paired against her. Equally likely to be paired against her. The table below shows that the chances of Bhavani losing when paired against each opponent are given. Opponent 1, the Bhavani chance of losing is 12%. With opponent 2, 60%. Opponent 3, X%. And opponent 4, 84%. If the probability that the Bhavani loses the game that day is 1/2. To find the probability for Bhavani to be losing the game when paired against opponent 3. Show your steps. This is a question asked in 4 marks ago. 4 marks question. This is somewhat a different way they asked. The probability that Bhavani loses the game that day is 1/2 is given. That means it is, I think it is, the total probability is 1/2. What we call it as A. Let the E1 be the event that she paired with the opponent 1, and E2 is the event that they paired with the opponent 2, paired with the opponent 3, and paired with the opponent 4. So the respective probabilities are given. Yeah. Sorry, not the each equally likely means it is 1/4. The probability of E1, E2, E3, etc. E4 is 1/4. And the probability of E1, A given E1. A is the event that Bhavani losing the game. Bhavani losing the game paired with each opponent. That is probability of A given E1. By that we can do 1 minute. There is no place here. Let E1 be she's paired with opponent 1. let E2 be C is paired with the opponent 2. E3 be the event that C is paired with the opponent 3. And E4 is the event that C is paired with the opponent 4. So the probability of E1 is equal to probability of E2 is equal to probability of E3 is equal to probability of E4 is equal to 1 by 4. Now, let E be the event, let A be the event that losing the game, Bhavani losing the game. Bhavani losing the game when paired with against each other. So probability of A given E1 is equal to 12%, that is 12 by 100. So probability of A given E2 is equal to 60%, 60 by 100. So probability of A given E3 is equal to X percentage. So the probability of A given E4. Sorry. A given E4 is equal to 84%, 84 by 100. Now, what is given that if the probability that Bhavani loses the game, the probability of A is 1 by 2. So, what is given that the probability of A is equal to 1 by 2 is given. That is the probability of A is probability of E1 into probability of A given E1, 1 by 100, plus 1 by 4 into 60 by 100. So 1 by 4 into X by 100 plus 1 by 4 into 84 by 100 is equal to 1 by 2. Given already, it is 1 by 2. Sorry. So here, that 400, 1 by 400 can be taken out in all the common. It is 12 plus 60 plus X plus 84 is equal to 1 by 2. This is cancelled by 200. So 72, 76, 156 plus X is equal to 200. So X is equal to 44. So 44% with the opponent 3. With the opponent 3 is 44%. So now the question is the probability that Bhavani loses the game today is 1 by 2. Find the probability of Bhavani to be losing the game and paired against opponent 3. So that means what is the probability of A3 given E? That's the question. What is the probability of E3 given E? So probability of E3 into probability of A given A3 divided by, that is the probability of A, that is the total probability we can have. So 1 by 4 into A given A3 is 44%, 44 by 100, divided by probability of A is 1 by 2, right? This is 11 by 100. So if we take 2 that side, so 22 by 100 or so 11 by 50 is the required probability, right? So when you see paired against opponent 3, Bhavani to be losing the game when paired against opponent 3 is 11 by 50. So this question is somewhat a different way. They asked the total probability they given as 1 by 2, and then we have to find the value of X from that. Then I have to use the Bayes theorem so that I can find the answer. This was little tricky questions, and then they have students, they may find it. Some students, below average students, general, those who are using the Bayes theorem, so they will find it difficult. Below average children, they find it. Average children, they may do it, 90% they will do it. And the toppers, definitely they will do this question. And the low achievers, maybe they find it difficult. A bag contains 3 red and 7 black balls. A bag contains 3 red and There are 7 black balls. 2 balls selected at random, 1 by 1, without replacement. If the second ball selected is a red color, second ball selected is a red color, what is the probability that the first selected ball is black? What is the probability that the first selected ball is black color? And what is the probability that the first selected ball is a red color? Okay. The first selected ball is a black color and the first selected ball is a red color. How to do that? A pack contains 3 red and 7 black balls. 2 balls selected at random, 1 by 1, without replacement. So, slide. Okay. A pack contains 3. What is it? 3 red and 7 black. Let E1 be the first selected ball. The first selected ball is black. And E2 be the first selected ball is red color. So the probability of E1 is equal to 3 by 10. The probability of E2 is equal to 7 by 10. Am I right? Oh, sorry, it is E1 is first black ball. 7 by 10, sorry. This is 7 by 10, this is 7 by 10. It's a 3 by 10. And then E1 is first selected ball is black color. Right? 3 red and 7 black. And then what is that? The second selected ball is red. Let A be second selected ball is red color. Second selected ball is red color. So probability of A given E1. What is the probability of A given E1? So the first selected ball, A given a second selected ball is red color. Given that the first selected ball is black color. First selected ball is one ball is selected is black color. What is the probability that the second selected ball is red color? Red color means it is how many? It is 7 by second selected ball is red color. So here it is 3 red and a 7 black ball is here. Already first selected ball is black color means 6 black, 1 black color is selected. So 3 red and 6 black will be there. It is and then now what is the probability that second selected ball is a red color? So it is 3 by 9. And the probability of A given E2. So the second selected ball is red color, given that the first one is also red color. So it is 2 by 9. Okay. It is red color means 2 by 9. Because already one ball is selected and taken out. Therefore, remaining balls will be 9 only. In that, already 1 red ball is taken. Therefore, 2 red ball remains. Therefore, 2 by 9 is the probability. So the question is, both the balls are selected. E2. So probability of the question is what? E2 given A or given what is the probability that the first ball selected is black color?
Yeah.
Sorry, it is first of all selected is black color means E1 given E. Probability of E1 given E. What is the probability of E1 given E? Probability of E1 into probability of 7 by 10 into probability of A given E1 3 by 9 divided by 7 by 10 into 3 by 9 plus 3 by 10 into 2 by 9. So the answer is 21 divided by, that is 1 by 10, 90, 1 by 90 gets cancelled. So 21 divided by 21 plus 6. So 27. It is 7 by 9. Is the required probability of the first question. Yeah. Then the second question is, what is the probability that the first selected ball is also red color? The first selected ball is also red color. It means E2 given A. What is the probability that E2 given A? So E2 given A means probability of E2 into probability of A given E2. Dividing the denominator the same. You can find out the answer for the second subdivision. Yeah. So probability of E2 given A is equal to, Madam, Uma, Madam, I think, please, yes, thank you. E2 into probability of E2 is 3 by 10 into A given E2 is 2 by 9 divided by the same 7 by 10 into 3 by 9 plus 3 by 10 into 2 by 9. So we take that 6 divided by 21 plus 6. So 6 divided by 27, that is 2 by 9. The answer is 2 by 9. Second subdivision 2 by 9. First subdivision is 7 by 9 is the required probability. Yeah. So somewhat a different question. Case study questions, easily they can get marks. So that we have to explore many questions. Then only they will do without any hesitation, without two mistakes. There are a lot of mistakes, lot of questions we found it. Here it is. Yeah, this question often they find it difficult. Some questions, some students they do mistake also. In it, this is a very famous question. Many of the test exams they are asking these questions. In a test, an examinee either guesses or copies or knows answer to a multiple choice question with the 4 choices. The probability that he makes a guess is 1 over 3. And the probability that he copies the answer is 1 by 5. The probability that his answer is correct, given that he copied it, is 1 by 8. Find the probability that he knew the answer to the question, given that he correctly answered it. Okay. So little tricks to they can understand. If they understand, they will do it. Somewhat problem is yeah, the examinee either guesses. So let E1 be the student guesses the answer. Guess the answer. And the E2B, the student copies the answer. Student copies the answer. And the E3B, the student knows the answer. He knows the answer. Sorry. So to the probability that he makes it guess, it is the probability of E1 is equal to 1 by 2 is given. And the probability of E2 is the copies answer is I think it is 1 over 5. So what is the probability of E3? So that is equal to, because E1, E2, E3 is a partition of the sample space. So they are exhaustive events and then the sum of the probabilities is 1. So probability of E3 is equal to 1 minus 1 by 3 plus 1 by 5. Okay, the remaining is the probability of E3. So this they have to find out. Okay. 1 minus it is 15 with the LCM. So 5 plus 3, 8 by 15. 1 minus, sorry. So 1 minus 8 by 15, it is 7 by 15. It is probability of E3 is 7 by 15. And what is A? That A be the given that the answer is correct. He answered correctly. Or he or she answered correctly. So probability of A given E1 is what? So the probability A given E1 is he answered correctly, given that he guessed the answer. The guess answer means it is the chances of 4 multiple choice questions. Therefore, it is 1 over 4. It's not given, but you have to guess. You are right. It is understood that it is 1 over 4 because it has the 4 multiple choice questions with the 4 choices. So probability of A given E2 is copies. It is given that it is 1 by 8. And the probability of A given E3. What is A given E3? He answered it correctly. Given that he knew the answer, he knows the answer. He knows the answer means definitely he will answer the question correctly only. Therefore, the probability is a sure event. It is 1. So the question is, what is the probability that he knows the answer? A3 given A. What is probability given A3 given A? He knows the answer. He knew the answer to the question, given that he correctly answered it. So E3 given A. What is E3? Probability of E3 is 7 over 15 into E3 into 1 divided by, and then probability of E1 into probability of A given E1. So 1 by 3 into 1 by 4 plus 1 by 5 into 1 over 8 plus 7 by 15 into 1. So if you simplify, you will be able to get the answer correctly. So if you simplify 7 by 15 divided by, you take LCM of 12 and then 40 and 50. And then if you add that, you will get the answer. The thing is here, this part is very, very important. So here the students should be able to answer the question. This is the probability of E3 and this must be 1 and this must be, these are 3 things they should know. Otherwise they will blink it. So below average children, this question is a famous question. So we have to tell them all these points. When it is missing, they will find it difficult to find out how it is done. Because they will try to manipulate the problems, the numbers, what is given. Just they will apply it to the formula only. They will know only the formula and then they will apply. They will not understand the question. So ask them to read the question 3 or 4 times or 5 times until they understand. And then what they are asking, what is the base of the question. So with the multiple choice question means chance of guessing is 1 by 4. They should know this fact, all this. If they know that this problem they can handle very easily, they can get the full score. Okay. Any question, teachers? Shall I go to the next question? Yeah, this is also one of the important questions. We have, I think, many of them discussing in the class or not, I don't. The letter is known to have come from either Tatanagar or Calcutta. Calcutta is the old name of Kolkata now. On the envelope, just 2 consecutive letters, maybe some other words also they may give. So this is an example question that you can do it. This is a very famous question also. Many times they asked. One time they asked the exam, other exams they asked. On the envelope, just 2 consecutive letters TA are visible. Only TA only visible. What is the probability that the letter has come from Calcutta or Tatanagar? Second one is Tatanagar. Come from Calcutta is one question. Come from Tatanagar is another question. Okay. So this is also by using the Bayes theorem we can solve the question. a letter is known to have come from either Tata Nagar or Calcutta. Okay. So let us take the events as E1, E2. Okay. Let E1 be the letter came from Calcutta. The letter. And E2B, the letter came from Tata Nagar. Okay. Therefore, what is the probability of E1? So it is equal chances only. Because we cannot guess it is a TA is a visible means we cannot guess that. So probability of E1 is equal to probability of E2 is equal to 1 by 2. It is either from Tata Nagar or either from Calcutta or from Calcutta. So let A be the event that the two consecutive letters TA are visible on the envelope. No? That is given. Let A be the event that two consecutive letters are visible. Two consecutive letters. That's important. Consecutive letters TA are visible on the envelope. On the envelope. So that is probability of A given E1. What is the A given E1? So TA letters visible from there is two letters TA are visible from the envelope, visible on the envelope, consecutive letters. Given that it is came from Calcutta. So Calcutta means the two consecutive letters you can write it as CA, two consecutive, or AL, two letters, consecutive letters, LC, CU, and UT, then TT, then TA. 1, 2, 3, 4, 5, 6, 7. So only one TA is available. So 1 out of 7. The probability is 1 out of 7. TA, consecutive letters. So probability of A given E2 is the consecutive letter TA is visible on the envelope. It came from Tata Nagar. Tata Nagar means TA is one consecutive, AT and TA and AN, then NA, AG, GA, and AR. Am I right? I think 1, 2, 3, 4, 5, 6, 7, 8. So 8 letters, 8 consecutive letters are there. In that 2 consecutive letters are TA comes. So the probability is the 2 over 8 or 1 over 4. Right? The probability of A given E2 is 1 over 4. A given E1 is 1 over 7. So the question is, what is the probability of first one is Calcutta. Calcutta means E1 given A. So probability of E1 is 1 by 2 into 1 by 7 divided by 1 by 2 into 1 by 7 plus 1 by 2 into 1 by 4. Yes. So 1 by 2 is common, take it out, cancel. So 1 by 7 divided by 1 by 7 plus 1 by 4. So 7 into 4, 28 is LCM. So 4 plus 7. So 11 by 28. Yeah. So 1 by 7 into 28 by 11. It is 4 by 11. His answer is what? 4 by 11. It came from Calcutta. Is 4 by 11. What about the second question? It is from Tata Nagar. Tata Nagar, if we take that, it is the remaining 7 by 11 is the problem. Yeah. You will get the same answer like the same way. E2 given A. E2 given A is 1 by 2 into 1 by 4. Just if we do that, 1 by 4 divided 1 by 8 divided by 11 by 28. So 1 by 8 into 28 by 11. If we do that, 7 by 11. I think so. It is 7 by 11. 8. 1 by 2 into 1 by 4. 1 by 8. Sorry, 1 by 4 only. 1 by 4 only. So 7 by 11. The answer is 7 by 11. So for Totanagar, it is 7 by 11. For Calcutta, it is 4 by 11. Yeah. So the consecutive letters, how to arrange, and then how it is visible. Okay. This concept we have to teach them, so that once they explore, they will do it. And then I hope you explain all these type of questions. Anyhow, just from my side, I am reminding them all this. Next, this question was asked in the board exam. Okay. It's a 2009 All India paper. That time, this also many of the children did wrongly. Yes. Where they do mistake, you have to see that. Colored balls are drawn, are distributed in 3 bags as shown in the following table. Okay, they say like a textbook question, but it's not like textbook question. Textbook question is one ball is a bag is selected at random, and then 2 balls are randomly drawn. But in the textbook, it is only 1 ball is drawn. 1 ball is drawn easily, you can do that. But the 2 balls are drawn, little bit they have to do is combination. Better if they use combination is better. Randomly drawn from the selected bag. They happen to be black and red. They happen to be black and red. What is the probability that they came from bag 1? So bag 1, there are 1 black, 2 white, and 3 red. 36 balls are there. Like that, bag 2, it is 7 balls are there. Bag 3, 12 balls are there. With the different colors, 3 colored balls. Okay. A bag is selected at random. So choosing bag 1, E1 is choosing bag 1, E2 is choosing bag 2, and E3 is choosing bag 3. So 1 by 3, 1 by 3, 1 by 3 is the respective probability of choosing bag 1, bag 2, bag 3. But A will even that the 2 balls drawn, randomly drawn from the bag, selected bag, or happen to be black and red. 1 is black and 1 is red color. So A given E1. Now, what is the probability of A given E1? So, probability of this, if they find it correctly, then answer will be easier. So, probability of A given E1. So, the 2 balls drawn are both 1 black and 1 red, given that it is taken from bag 1. So, 1 black ball and 1 red ball. There are 1 black and 3 red balls are there available. So, how do you select 1 black ball? Is equal to 1C1 into 3C1 divided by 6C2. It's the way of selection of balls. If we do that, it will be much easier. Okay. So 1C1, one black ball to be selected out of 1 ball, that is 1 way. 3C1, so 3 ways. So 1 into 3 by 6C2. There are total 6 balls. Out of that, 2 balls to be selected. So 6C2 ways. So 62 is equal to 6 into 3, 6 into 5 by 1 into 2. So it is 15. So 3 by 15 or 1 by 5 is a required probability that A given E1. What is probability of A given E2? Probability of A given E2 is only finding difficult. Second, so 1 black ball into 1 red ball, 1C1 divided by 7C. Get totally 7 balls are there. So 2C1, 2 into 1, 2 divided by 7C2 is 7 into 6 by 1 into 2, it is 21. So 2 divided by 21. And the probability of A given E3. Probability of A given E3 is what? 4C1 into 3C1 divided by totally 12C. 12C. So 4C1 into 3C1 is 4 into 3 divided by 12C2 is 12 into 11 by 1 into 2, 66. So 12 by 66. That is the 2 by 11. It is 2 by 11. So the probability of A given E1 is 1 by 5. Probability of A given E2 is 2 by 21. A given E3 is 2 by 11. This way, if they find it, they won't do any mistakes. I think many students, they did the mistakes in that year, 2009. When I was correcting the paper, I felt very bad. Many of them wrong. Many of them, out of 10 papers, one may be correct. Sometimes out of 50 papers, if you do that, 1 or 2 students only did correctly, or the whole 6 marks that is. Many of them went wrong. Here, I think finding this one. So probability of E1, probability of E2, probability of E3, everyone correct. 1 by 3, 1 by 3, 1 by 3. That if they do correctly, we can give 1 mark like that. And then the formula, if they written half mark. So 1.5 marks maximum or 2 marks maximum they got out of 6. This all this they went wrong. Probability of A given E1, probability of A given E2, etc. All this they did a mistake. So this question to be taught to the children, because the textbook, it is only one ball is drawn. That is easily to, you can find out, you can do that question very easily. But here it is 2 balls means they have to use combinations. Otherwise it will be something wrong.